and immunity. So first I want to just give you guys an appreciation of the cardiovascular function of the lymphatic system. Because most of you are going to be dealing with the lymphatic system very frequently as it's related to cardiovascular failure and other inflammatory issues that actually are based on the cardiovascular system, not necessarily the immune system. Even though the textbooks always organize lymphatic and immune, we don't know much about either one of these systems, so there's not quite enough to fill entire chapters. The immune system is still not very well understood. It's very hard to study. And then the lymphatic system is really hard to study, and it tends to be mostly studied from the point of view of the cardiovascular system. But for whatever reason, the 300 level textbooks don't group the lymphatic function into the cardiovascular system. So let's talk a little bit about the lymphatic system's overall big picture function. So I'm going to draw a capillary bed in a really simple way. It's going to be some tubes. We'll do that, yeah. So highly simplified capillary bed. Blood's coming in from the left-hand side, blood's going out towards the right-hand side. Capillary bed's in the middle. So up until this point, a lot of us thought about, okay, blood goes out and these little lines will just be the red blood cells. Blood's coming through, and capillary beds are really small, so the lines I'm drawing are actually relatively close to how big red blood cells are. They barely fit into capillary beds. That's why if there's anything that causes them to swell, like high blood sugar, you will actually get issues with blood flow through capillary beds. So a lot of the symptoms you hear about with type 2 diabetes have nothing to do, well, it's not so much the sugar in general, it's what the sugar does to red blood cells. It causes these all to swell. And so in capillary beds, you tend to have issues. And nervous tissue is the most sensitive. So neuropathies are common because nervous tissue, if it lacks blood flow, it's going to have problems. Well, type 2 diabetes and uncontrolled type 1 diabetes do cause swelling of the blood cells. But now we need to step back and not just look at the red blood cells, because that's not the important part in the lymphatic system. Because red blood cells, unless there's trauma, red blood cells don't leave the capillary beds. They stay in our closed circulatory system. But our capillary beds they are leaky. They have holes in them because the cells that border our capillary beds are actually contractile. Muscle cells are not the only thing that can contract. They can adjust how permeable they are, but there's cracks all over the place. But notice the cracks aren't big enough for the red blood cells to fit through. I've drawn them too skinny. They're kind of anorexic red blood cells, and it looks like they might be able to slip out. They can't. Those holes, though, they let water go out, they let salts, sugars, all this stuff that if you're a cell living, trying to just hang out and get all your nutrients, you don't want a totally closed tube. You need to leak out everything you need. So water, sugar, all this stuff is going to head out right at the beginning of the capillary bed. There are no holes in the arterioles, which is what this one is, the smallest of the arteries. There's no holes there. There are holes only in the capillary bed. So that's when the hydrostatic pressure, so the pressure in the blood, pushes the fluid out so it can bathe the cell. The cell can just bask in all this sugar. It can wash away its wastes. You're kind of watering the cell. It's like one of those leaky hoses that you use to slowly water plants. Now it's going to leak out all over the place, but I'll just draw the arrows up at the top. Now, what's the problem if we just let water leak into the interstitial space?
It swells.
It swells, so what do we call that? Edema, right? So edema building up is usually an uncontrolled or too much leaking going on, because what I'm displaying here is the normal situation. But we don't want to just let it come out. In reality, what happens, we'll talk about exactly how this happens when we get to the kidneys. The kidneys don't do this, but it's a concept that we'll get in more detail with when we get to the kidneys next term. But you're going to reabsorb. You release fluid at the beginning of the capillary bed, and then you reabsorb it at the other end. But there are 5 arrows there, and there are 4 arrows there. And I didn't do that by accident. What I'm trying to illustrate is that you actually filter more out than you reabsorb. So there's a certain percentage, and it varies dramatically based on the tissue and what you're doing, but a good way to think of it is something in the range of about 10% of the fluid that comes out of the capillary bed doesn't get reabsorbed. So if this were the end of the story, we would constantly lose 1/10 of our blood volume as it moved through capillary beds, which would not be a good idea. So this is why the cardiovascular system absolutely needs the lymphatic system, which is a second set of tubes that capture the 10% that's not reabsorbed at the capillary bed. And it returns it back to the venous blood. So your blood volume is less in the venules, but by the time the lymphatic vessels merge with your veins and you get back to the heart, you've got enough blood. You don't lose your blood volume. And so that's the main role from a cardiovascular point of view. That's why the lymphatic system is so important for maintaining blood volume. If you have a parasite or something like that that starts to sit in here and just blocks up your lymphatic system, you're going to get rapid edema. This is what elephantitis works like. If you ever seen someone with, probably haven't seen anybody, it's very uncommon in the United States. But in other developing countries, there's parasites that live in less water that is a little bit less safe to drink, and it actually gets into your lymphatic system and blocks the lymphatic return. Surgeries can also do this though. So if you have parts of your body removed and with it comes the lymphatic vessels, like a lot of times happens in cancer surgeries, whatever region of the body this vessel is draining is going to swell. It's going to cause edema. And another reason that you might get edema, and this is the real cardiovascular one, that many of you have probably seen but not totally understand why it happens. So if someone has heart failure, when they get to the later stages of heart failure, they balloon up. This is what happened to my grandfather. When he had aortic valve stenosis, and so his aortic valve is narrowing slowly over about a 20-year period. So it's narrowing and narrowing and narrowing, and at a certain point, he could no longer pump the blood that his heart was getting. And so his heart did two. One thing, his heart it stretched, and that was a very dangerous thing. But what ends up really happening is that the venous blood flow, gets in a traffic jam, right? So if you pinch off the one exit to the heart, then you're going to have a huge traffic jam in your veins. And if you have a traffic jam in your veins, if there's a red blood cell here that's like trying to go this direction, trying to go forward, but can't, there's a bunch of blood there, all of a sudden the filtration goes through the roof. Because now you have, think about a hose with water running and just pinching that off. You're going to have tons of pressure filling up your entire body. And that's essentially what happened. My grandfather's almost the same size as me. He's probably a little bit lighter, but he's probably 160 pounds healthy. And he went to like 192 in about 12 hours. And so it was a rapid drop off. It's not a progressive thing. It's something that all of a sudden the heart can't handle what you're asking for it. And when that happens, you get rapid edema accumulation. And so that's how this relates to the cardiovascular system. The way it relates to the immune system, I don't have to alter the drawing much at all. Just add a lymph node. So an immune system, if you were trying to evolve a way to capture infected stuff, so let's say our happy little cell here has got a virus in it, or actually viruses are a little bit too complex. Let's just say we've got a nasty staph infection. That'll be our bacteria. It's all over the place, both inside and outside of cells. It's all nasty. The infection is not in the blood yet. A lot of times when we think of infections, we think, oh, they must be in the blood. No. Your body tries to keep them out of the blood. Does two things to do that. Number one, if you get an infection out of here, this cell releases cytokines and things like that. All these inflammatory things is where the inflammation comes in, and it says, hey, capillary bed, close off. Stop this. Narrow the capillary bed. We don't want to accidentally leak bacteria in and let it get back to the heart and have it go everywhere. By pinching off this capillary bed on the end of it, you force fluid into the interstitial space. And that's really nice because that's the way the white blood cells get forced in there too. You start bringing your blood flow to the infected area, but you reroute all of the inflammation through the lymph node, which is where all your white blood cells are sitting. Well, not all of them, a lot of them. They're hanging out in here ready for the fight, basically. And so this is your normal response. You get this inflammation and swelling because you've pinched off this capillary bed. But the beauty of that is that you then take the bacteria and you force it to go through your best defenses, which are lymph nodes and tonsils and things like that. All a bunch of places where white blood cells hang out. And they can launch an immune response and adequately deal with it. So it's just like the liver was sort of dealing with the problem before it got back to the blood. Lymph nodes are basically doing the same thing, but for infections. And so this is one of the reasons lymph nodes swell up when you have an infection, because you're actually forcing more volume into them. And they'll get tender because the inflammation can actually travel to the lymph node. So that's where it's almost out of convenience that too many systems in my head. Your immune system sits waiting in your lymph system. The lymphatic system first evolved to manage blood flow and cardiac output, and then immune system said, hey, this is a great place for us to hang out. If you could hang out anywhere, it'd be the lymphatic system. So that's how the two intermingle with each other. Edema is just going to be something causing more secretion or release of fluid at the capillary beds than you recover. So, any questions about that? We'll talk about the physical mechanism of the reabsorption and how it relates to proteins and why starvation causes swelling and that kind of stuff when we get to the kidneys. But that's kind of the basic, kind of big picture doodle sketch that you can kind of think of to explain why people swell up during cardiovascular failure and then why your lymph nodes swell up when you're battling an infection. So if we take the next picture I'm going to look at is